So yeah, I've entitled this talk Demand Side Energy Transformation, Ambition and Justice. And the theme of my talk is that we need to focus a lot more on the demand side in thinking about energy transitions towards meeting the Paris goals of ambitious climate mitigation. And there's two reasons, broad reasons. One of them is when we look at the demand side, there's an efficacy issue. I think I'm going to show that it really is possible to reduce the challenge of the energy transition by looking at the demand side. It can reduce the cost of it. It can reduce the speed of it, increase the speed of it significantly. So there's an efficacy issue. And secondly, we can start looking at justice much more clearly when we look at the demand side. And those are the two main motivations for this. So I'm going to talk a little bit about my motivation. I'm going to present a vision of a demand side transformation that is a little bit more than just my work. It's an integrated assessment model scenario that was published recently that I think is very important for people to understand. What will it take if we were to really push the limits on the demand side, and how does it really change the view of the global mitigation challenge? And then I'll talk more specifically about my work in terms of poverty eradication and some of the opportunities it creates for looking actually at low carbon development. I think you all probably know that we are on a path to a climate stabilization level that exceeds the goals of the Paris Agreement, and probably substantially, maybe in the 3 to 4 degrees centigrade range. And we are kind of on the trajectory of barely achieving the policies that have been pledged. You know that there are voluntary pledges in the Paris Agreement that countries have made, and some of them are conditional, some of them are unconditional. So we are, kind of at the top end of the window of, or the fan of emissions pathways associated with these pledges. And so, and even those pledges in their best achievement are not getting to us to the blue path, right? Which is a rapid and very drastic turnaround in emissions. So we need more ambition. And it's really important because we've heard time and time again that the disproportionate impact of climate change is on poor people, vulnerable people in other countries outside of the industrialized countries that have contributed most of the emissions so far. And so there's ambition is justice in a way. And so it's really important to ramp up that ambition. And we are, of course, facing a lot of political challenges and many other challenges to do that. And so there's been interest in the community to think about how might we make this transition without relying on technology risks to the extent we are today. Because as we get further and further away from, as we keep going forward in time without taking action, serious action, the models that we project of future stabilization involve negative emissions technologies increasingly. The 1.5 degree report from the IPCC has these 4 sort of archetype pathways. As you go right, they're showing an increasing reliance on what's shown in yellow is BECCS, which is bioenergy-based carbon sequestration, carbon capture and storage, which is effectively using biofuels as a source of energy, but then sequestering the carbon, so you end up with net negative emissions. But it's really almost fictional at this point. There's, of course, many other forms of carbon capture through afforestation and forest management that are much more promising, that people think about a lot more today, but it still is very ambitious. And so there was a scenario that was undertaken by IASA where we looked at, okay, let's focus on the demand side. If we can really reduce energy demand, then can we do it and achieve the 1.5 degree target without relying on BECCS? I mean, we still would have some afforestation targets, but it would be significantly less than these negative emissions-based technologies that we don't really have any comfort in. So that's the study I wanted to talk a bit about. This is the reference if you're interested. And this is the scale of energy demand. I wanted to put that in perspective. So where we are today is around 400 exajoules of energy demand And there's various scenarios that have been undertaken by different organizations looking out into the future to achieve to 2 degrees C or 1.5 degrees C. So these are all different scenarios of 1.5 degrees C from different organizations. You don't need to worry about uh, um, who they are and what the acronyms mean. So this is the International Energy Agency. This is below 2 degrees scenario. And all of them, basically expect or project a kind of a flat energy demand trajectory for the globe, which is pretty impressive already, considering that developing countries expect to grow their energy demand. So this is assuming very high levels of energy efficiency. But if you look at this study, the LED study, and let me just put on my pointer. Where did it go? If you look at the LED study, this is reducing global energy demand significantly. So this is really a heroic view of how we might proceed in the future. And this is reducing energy demand without reducing the level of activities that energy demand or the services that energy demand provides. And so it's really ambitious, and it's definitely transformative, but in a different way. There's a principle that underlies this argument about it increasing the efficacy of decarbonization. And that's a principle I like to show in my class, and people are familiar with this in the energy research, but those who are not may find this interesting. Essentially, there are a lot of losses in the energy supply chain, right? Especially with fossil fuels. There's a significant amount of heat losses when you generate electricity. This is the electricity system. I'm giving you an example of the amount of energy that you need to generate to provide a unit of service to people. So if you look at this energy supply chain, as you go from coal extraction from the ground to electricity production, to transmission and delivery, and then this is the electricity at your doorstep, at your meter, and then the energy losses in the end-use devices in your light bulb. And then if you consider the useful services you get from lighting are only when you're actually in a room and lights are on, right? So you consider idle lights. If you think about commercial lighting, like in Manhattan, all night you have buildings that are lit. You're literally generating 100 units of energy in the physical coal product to get 1 unit of illumination. And so imagine if you had motion sensors in every single room, indoor space in the world, and you reduce demand by a factor of half, essentially, right, from 2 to 1, and you get rid of all this waste, you avoid 50 units of production. And so that's this knock-on effect. It's this leverage that you have of reducing demand avoids supply by a disproportionate margin. Of course, this is an extreme case that I'm showing you. When you move to a renewable-based system, you don't have these heat losses. On average, this knock-on effect is like a factor of 3 to 5 overall in an energy system across the world. And that's significant. And you get a sense of this even if you look at other types of energy demand. If you look at your heating furnaces at home and how you set your temperature, if you just change it by 1 degree, you may not notice any difference in comfort, but you may have a huge propagating effect on energy supply. Food waste, automobiles, if we drive smaller cars, similarly, you have a huge knock-on effect. So that's the principle about why demand-side changes have this greater efficacy. It reduces the burden of decarbonization effectively. So what does this vision entail? There's several principles. One principle is increasing utilization. So the idea is that we think less about owning resources and buying resources, but utilizing them more. Automobiles sit idle 90% of the time. When everybody has their own washing machine in their home, it sits idle most of the time. If you use a laundromat, then that machine is being used a lot more. So you can think about using resources, using vehicles, customers who are able to share devices by communicating with each other, sharing spaces. All of this leads to investing in less physical capital. And even consumer products, if you hold on to your cell phone longer, your clothes longer, you will have, on a life cycle basis, less capital investments in energy, and that is going to be much more beneficial for the climate. There's also behavioral change. We're talking about reducing consumption, although a lot of it may not really require a loss in our well-being. So, for example, waste reduction. A quarter of the food in the world that's produced is wasted for different reasons across the world, right? We know about waste in energy, as I just told you, and then consumer products like plastic, which incidentally with COVID is people are just salivating, you know, companies that make plastics with the amount of increase in plastic use. We're talking about conscious consumption, as I mentioned, with thermostats, motion sensors, walking or cycling to do groceries, for example, when you can. But also there's an assumption of moderation in terms of consumption. So the scenario looks at having smaller houses. So we max out at 30 square meters a person. That's 300 square feet a person. Also, lightweighting cars, having smaller cars, and changing diets to be less meat intensive. We incorporate all of these changes in the scenario. And there are structural changes that we expect in the economy, including, of course, electrification of transport, because it's much easier to decarbonize electricity than it is to decarbonize engine fuels. Dematerialization of products, like I said, through lightweighting of materials, through more efficient materials, and also thinking about urban form, where you have more dense development of cities so that people can commute to work through non-motorized means. So these are sort of, this is the vision behind some of the numerical assumptions that have gone into this. And another important aspect of this is that, you know, what's very heroic is that this is about technology diffusion across the world. An important premise of this study was that we're not relying on any technologies that are not commercially available today. However, the challenge is instead of technology adoption and diffusion across the world, not technology development per se. Here are a few examples of how we represent demand in the key sectors. So buildings, we expect that you can reduce the energy intensity of buildings by a factor of 6 by using passive housing. And again, this is based on existing examples in developing countries. Well, Mexico is kind of on the cusp. Netherlands and Austria have examples, even of a commercial building, of basically a zero net energy indoor space. Of course, we're not looking at affordability. This will be propagated across the entire world. But nevertheless, this is possible today, is to have a net zero energy building in a space where you need cooling energy in some places and in others where you need heating. In transport, the idea is really a mind shift from owning modes of mobility to sharing modes of mobility. What we really care about is services, right? Is travel needs, is to get from A to B, is to get our children to school, to get groceries, not necessarily to own vehicles and drive ourselves, right? So there have been experiments and simulations that have shown, for example, in the city of Barcelona, where you can take away 90% of the mobility infrastructure of cars primarily, and yet meet people's travel needs just with very efficient use of resources and with a lot of smart consumers with access to information about each other in real time. So there's car sharing, of course, EVs, bike sharing, and a large emphasis on public transit, especially in developing countries. And what results from this really is occupancy increase. That's the primary goal of this, is occupancy increase, and to not let these vehicles sit idle. And what we end up with is an estimate that the global vehicle fleet reduces in half compared to a scenario where you assume kind of business as usual trends. Technology does have a role, and I would say, in fact, that this scenario is still technology focused, but it's more end-use technology focused. So in the transport, as I mentioned, there's a lot of new potentially disruptive technologies that have to diffuse across the world. E-bikes, different kinds of ride shares and bike shares, as well as avoiding travel altogether through remote remote telecommuting, right? And COVID, and if there's any silver lining in COVID, perhaps that is one of them, where people are now getting used to that. So perhaps it can be continued into the future. Although I do know from work in Davis that the transport story in COVID has not been a very positive story, but nevertheless, there is some potential for that optimism. In buildings, there's also scope for technologies. Heat pumps are almost a given in order to, again, electrify the provision of heat and decarbonize it. And the smart use of appliances also has system benefits through peak load reduction, markets for reuse and resale. I'm already involved in local markets here where you just give away stuff to people. And it's incredible. You post something on a chat and within seconds, somebody has come to take something that you don't use anymore and use it themselves. And that also requires information. And then at the system level, you do need technologies, essentially in terms of smart grids, to accommodate electric vehicles. To support load shifting, you need more sophisticated pricing mechanisms and knowledge about when to turn on your appliances and when not to, and how to make the system responsive to a two-way communication as opposed to a one-way flow of information, which is how the grid is currently built. And so technology is important. I think a theme that runs through all of these technologies is sharing. And a second theme that runs through all of these is information. And so we do rely on information technology significantly to build up a smart grid and a smart consumer in order to achieve this kind of demand side efficiency. So that's the very quick story about what a vision is for the future. But really, we haven't tackled issues of affordability. And it is therefore a transformative change that's heroic in its own way, right? So now let's consider what a demand-side transformation entails from the perspective of developing countries. Why do we need to think about this? And here I want to focus more on the justice issues, a little bit more implicitly. So poverty looms large in the developing world. If you look at income poverty defined by the World Bank's $2 a day threshold, especially South Asia and Sub-Saharan Africa, as opposed to China, although there have been millions of people brought out of poverty, at least as far as this threshold goes, you have a steady 800 million people who are still in poverty. And that's probably because people are born into poverty at a faster rate than they're coming out of it. And if you look at other deprivations that comprise poverty, so this is cooking with dirty fuels, which causes air pollution, that kills women and children prematurely, several million a year, you find the number of poor in Sub-Saharan Africa and South Asia increasing. If you look at the lack of sanitation or the number of people who lack sufficient calories, it's the same story, right? And this is now on the order of billions of people. And the SDGs intend to eradicate these deprivations in 10 years by 2030. So you can understand that developing countries are dealing with a heroic social transformation challenge already before you consider COVID or climate change or other crises. And now we have this challenge of climate change in the middle of all of that, which taken seriously, they present a real potential conflict for developing countries. So let's look at that trajectory again, where we need to bring our net global emissions down to zero as soon as possible. This is an illustrative pathway, one of many. And what I like about this paper is you see that about 3.5 billion people in industrialized countries and China have essentially industrialized and grown material consumption with cheap energy, and their emissions are not really reducing, right? They're pretty flat. There is a lot of decoupling, but we haven't seen turnaround really that's in any reliable fashion. And you have 3.5 billion people who are dealing with these enormous challenges of poverty that I just mentioned. And we understand that this would require significant amounts of energy. So how are these countries expected to invest in this massive decarbonization exercise while dealing with poverty, right? So that's the big climate development conflict that I've been interested in for so many years. But one I mean, it's also complicated because there's a lot of distributive justice issues this raises, but it's not so clear because the technology landscape is changing. You know, solar is now the cheapest form of electricity even in India. And there's a lot of investments that countries can make that they would make anyway. If you think about China moving away from coal due to air pollution, right? So it's not very clear how much growth is really required in the energy system to support these basic services, right? So that's the question that I wanted to pose that nobody has really been able to address is how much energy demand growth do we really need to provide basic well-being to all? Now, interestingly, this question has been around for 40 years. And the first time it came up was during the oil crisis for a different reason, when people were concerned about scarcity. And people were undertaking studies even then to ask this question. But at the time, all they could focus on, due to limitations in data and in analytical tools, was on direct energy services. But indirect energy use to support infrastructure, to provide basic services, people couldn't really calculate that. So we have not had an answer for a long time. So that's been the focus of my work. Currently, when we think about energy demand growth, we think about it in terms of income growth. And that kind of makes sense because material consumption is driven by income growth, and both energy demand and income growth are tied inextricably with material consumption historically. So this linear relationship is kind of expected, but this doesn't tell you a lot about poverty eradication per se, about basic well-being. We know that there are so many other dimensions to poverty that you don't capture with this. So if we just talk about eradicating poverty through, just simply linearly growing energy systems, we really have a very drastic picture in front of us, right? It seems totally contradictory with the climate mitigation goals. However, there's been a lot of analysis by researchers, including myself, into looking at the relationship of countries' energy demand to non-income indicators of progress. So if you sort countries according to their progress along non-income dimensions like basic needs or life expectancy or the Human Development Index, you see this non-linear relationship where countries have made a lot of progress with very little energy, right? So this is kind of indicative of the possible proposition that basic well-being may be less energy intensive than overall growth. But this is only suggestive evidence because there's no causation here. Something else may be going on that's driving both energy use and improvements in well-being. So I really set out to answer this question more rigorously. Now, how can we quantify the energy needs for basic well-being, for poverty eradication? And that was the focus of 4 years of my research. The grant that Alyssa mentioned at the beginning was really about this, using tools of industrial ecology and other kinds of energy modeling to calculate and quantify the energy requirements for poverty eradication. But the first step here is to understand what's the material basis of well-being, because energy is needed for materials. You don't need energy for psychological well-being, fundamentally, right? So there's a large number of indicators of well-being that have been developed in the last 30 years since the Human Development Index was first introduced in 1990. But the challenge is, how do you extract from this the material basis of well-being? And none of these indicators really explicitly tackled that, even though many of them included indicators that were very physical materials, right? So I actually spent a lot of time and effort into this question. And we developed an indicator called Decent Living Standards, which is a basket of goods and services, material goods and services that we argue is a fundamental prerequisite for well-being for people across the world, universally, no matter what their conception of well-being is, no matter what culture they come from. And this is a proposition that's based on theory. It's based on expert elicitation, drawing from other well-being indicators, as well as from empirical data showing that people actually want some of these components as they increase their income, as these things are affordable. So it's based on a lot of work, and I can't get into it right now, but I certainly can address it in the Q&A. but the main contribution here is that it's a set of indicators. And we've chosen thresholds for them as well, based on a lot of research. But the idea is that it's a set of indicators that I think is kind of non-negotiable in a modern society, what people, ought to have to pursue a decent life. And this is that basket. And again, I don't want to spend too much time going through it. Many of these are familiar. I'll just make a couple of points. One of them is that they are essentially aimed to serve physical well-being and social well-being. With regards to physical well-being, what may not be as intuitive, which is a little provocative, is we even consider the use of air conditioners where necessary to avoid excess humidity or excess heat stress, and argue that people ought to have some form of cooling. But we assume very minimal use. So literally only at night, only in bedrooms, and using a very conservative threshold, right? 26 degrees, no less. And heating only to 18 degrees, no more. We think about nutrition, not calories. We don't want just calories. We care about micronutrients like protein and vitamins and minerals like zinc and iron. And as I'll show later, that really matters for thinking about diets. Other stuff is pretty self-explanatory. But for social well-being, we also consider that in a modern society, people ought to have access to the internet and some form of device to access people as well as the internet. And people need to move around, right? People need some form of mobility so that the area of expanse within which they live for a job or for healthcare facilities expands. And so we also consider it essential that people have access to motorized transport, but not private vehicles necessarily. Public transit wherever possible. So that's the basis, the foundation for the energy requirements is what are the material requirements first and foremost. And from that, we calculated the energy requirements. And now I'm going to, make a huge leap by not discussing all of the energy analysis that went into this because it's very extensive, but we use tools of industrial ecology, building simulation modeling, and basic transport sector modeling to come up with these energy requirements. And I just want to show you some of the results. The first result is the gaps in decent living standards. We first started out looking at 3 countries, India, Brazil, and South Africa. And this is showing you the gaps in terms of the percentage of people lacking these services in blue, and then in red in 2030, based on current trends, how many people will lack these different dimensions of decent living standards. And the main point I want to make is India stands out as having the highest deprivations. The second point is that multidimensional poverty like this is much more insightful than just income-based poverty. So the acute income-based threshold I mentioned earlier underestimates the extent of poverty when you think about all the different deprivations that people experience. And so that I think is really interesting in and of itself. And Brazil and South Africa have different conditions. Brazil has 85% of an urban population. So they have a lot of amenities for various reasons in their past, but they have different challenges. Their challenges are more with regards to comfort in the home, sanitation, and nutrition, but they have many more amenities than do Indians. And so now I'm going to show you the energy requirements for these countries to fill these gaps in the future. I'm going to first show you results for India and talk about its composition before I talk about its implications for climate change and equity. So the first thing to notice is that we calculate separately the energy required to build out the infrastructure to provide these services. And then we talk about the energy required to deliver these services. And the first observation is in a country like India, to me, it was really staggering that the amount of energy we need to provide everybody with basic services by 2030 is within the amount we actually consume as a nation as a whole. It doesn't require doubling and trebling. It's of a comparable magnitude. But this doesn't mean that all of a sudden you can, redistribute. Of course, every country has a range of qualities of life and energy demand. But the point is that there's a huge equity a distributional issue here, even among developing countries. If you look at the components of what comprises this energy need, the construction, the infrastructure is driven by vehicles and housing. And if you look at the operation, it's dominated again by transport fuels and food production and cooking. What's important here is what's conspicuous by its absence. So in construction, you know, the infrastructure required to build out water and sanitation and hospitals and schools are trivial compared to housing and vehicles. And that is mainly because when you have a shared resource, like the other ones I mentioned, they don't work out to a lot per capita, whereas private resources end up being a lot. Again, food production is it's no surprise that it's extremely energy intensive overall, but what's absent here is air conditioning, for example. Over 80% of Indians would use some amount of air conditioning, but if you consider the minimal use I described, it's not that much. We also considered a climate-friendly scenario where we made assumptions that there'd be only public transit in future Indian cities, and we considered healthy diets and efficient building practices for construction, and you can reduce even the energy associated with basic living standards. So this was itself as a dramatic finding that the amount of energy requirements actually are quite comparable to existing demand. And now I'll show you 3 countries, Brazil, India, and South Africa. These are 2 different trajectories for basic living standards, and I'm comparing them now to the national trajectories for energy demand that models have projected in 2 degree C pathways. And I want to make 2 points here. First of all, the good news is it looks like these decent living pathways are kind of compatible with the 2 degree C world. Because even without considering equity, these are just sort of assumptions of technology diffusion and end-use technology diffusion. You see that there's headroom for increases in energy demand before you consider serious decarbonization or serious reductions in energy demand through efficiency and through advanced technologies. So that's a good sign. However, the amount of headroom that different countries have for this quality of life improvements or energy to support quality of life improvements is different. And that is an equity issue. So why do different countries face different challenges for decarbonization when you consider that they all have the same aspirations for living standards? So this does raise questions about equity, but at least we understand that basic living standards can be met even with very aggressive scenarios of future energy demand. So I think of this headroom as energy for affluence. And that's an important factor I'd like to have people think about, which is most of the energy that we think about in future growth is really about affluence and less about basic living standards. So there was a group in the UK that took my study and wanted to scale it up to the global scale. And we did that. It's actually not forthcoming. This paper is already out. I didn't update my slide. You can find it already. And this result is robust, namely that the amount of energy that we need to meet basic living standards globally, including industrialized countries, is about 25 gigajoules on average, which is but almost a tenth of the energy demand in the US, right? So all of this energy demand, you're looking at average energy use of countries in this figure, that most countries, their average energy demand is well above this level. And of course, there are a number of countries, mostly located in sub-Saharan Africa, that do have to grow their economy significantly to reach this level. But by and large, the main message here, something that we really did not know before this work, is that poverty eradication is not a threat to climate mitigation. The so-called development climate conflict is not about poverty eradication. It's really about the pursuit of affluence, which people, of course, ought to be entitled to, but we need to understand that that's what it is. And that's really important to me because we don't have this basic conflict about bringing people out of poverty and mitigating climate change. So now in the next phase of my research, I'm interested in looking at the affluence. And mainly the exercise is to understand the energy intensity of lifestyles. and that's the academic contribution. So let me give you an illustration. If you look at heat stress, you have two extremes where you have slums that have no way of affording air conditioners. They suffer heat stress. In the other extreme, you have the United States, where 60% of households have central air conditioning. 85% of households have some form of air conditioning. And then there's this sort of minimal cooling that we have used in this study, where you avoid heat stress, but you don't have, this convenience of cooling the entire home, and perhaps, indiscriminate cooling that also may fall into this category. You think about mobility, there's unsafe conditions of mobility in developing countries. In the other extreme, we have single occupancy SUVs in industrialized countries. And in the middle, we have the vision that I showed you of mobility as a service. And now we can quantify these lifestyles. And we can do this even for lifestyles that include indirect energy for consumer products, right? And that's the direction I'm going, which is not just direct energy, but thinking about lifestyles that involve all our consumption, and then thinking about their energy intensity, so that we can then think about where we can reduce demand without really affecting well-being. And this goes beyond conventional footprinting that you see, because this is really looking at an individual level, the heterogeneity in people's products and services at a scale that the traditional footprinting doesn't really get to yet. So that's broadly about how looking at energy demand really introduces issues of justice, and also illuminates a little bit about what's driving energy demand growth in terms of well-being. However, as I mentioned, there's opportunities for reducing energy demand growth even for basic well-being. So I want to dive into a couple of those examples. And this is the last thing I'll do before this presentation. Food, we've looked at food in India. And I want to mention again that I'm interested here in micronutrition, not just increasing calories. And so that puts a different spin on how we think about sustainable diets. If we look at global consumption of food, it's kind of interesting that even today, the bulk of calories are provided by plant-based sources. Even though there's really fast-growing meat consumption, even in developing countries, most people still don't eat meat because they can't afford it, not because they don't want to eat it. So we need to think about the sustainability of even plant-based diets. And I wanted to focus on cereals because poor people depend even more for their calories on cereals, up to 80% of calories. So I wanted to understand, if we look at grains that are nutritious in terms of these micronutrients, what's their environmental sustainability? Now, we understand already that there are two types of cereals with very different properties in terms of nutrition and environmental impact. So the C3 cereals are well known from the Green Revolution. They kind of have powered food production in the last decades, but they've come with very high resource intensity as well. So they have extremely high yields. However, coarse grains, and especially in India, have been crowded out by these Green Revolution grains, but we know they have better nutrition, lower water requirements, and lower energy requirements and greenhouse gas emissions. Especially rice, if you consider rice's methane emissions as well as nitrous oxide emissions from fertilizer, they just dwarf other grains. But the puzzle here is, we know it's better for the environment and for people, but if we shift production from rice to these grains, can you produce enough food? Because their yields are not high enough. And I'm talking here about white rice. Our focus here was on white rice because hulled rice has very low nutritional content. And hulled rice has been the predominant grain of choice in Asia. What was interesting, however, is when we looked at the data more closely at a regional level, we found that there was a range of yields. So this is yields across here, across different districts in India, for rice in beige and for the alternative grains in blue, for two different types of millets. And you see a big area of overlap, which tells us if we shift production from rice to coarse grains in these areas, we won't sacrifice production levels. So we set out to investigate how far we can go. And we also looked at a drought year, that we looked at the hit that grains would take in a drought year for rice, which is much bigger hit that rice takes compared to the hit that coarse grains take. And so we did an optimization study where we looked at changing land use cultivation patterns by maximizing nutrition or climate resilience or minimizing environmental impact while we ensured that total production is the same. And we looked at a scenario where historical land use was a basis for constraining how we shifted the production of rice. And so the results were basically telling us that it's a win-win. There were no real trade-offs. We can shift production by up to 20% without compromising on environment or nutrition. This is just a cute figure to show that. The black line in these snowflakes is the baseline, and the wedges are showing you the results of the optimization. And you want the bar to be outside the black line for things that you're trying to improve, like nutrition. And for environmental impact, you want the wedges to be inside, as they are. Okay, so that's the main result, and it's very promising. We've even had interest by policymakers in India, but there's a lot of political economy around rice. And there's also issues about, can farmers really shift to these other grains? Will people eat this other food? But the main point I want to make here is that if we had just thought about sustainable production as calories, we would talk about growing more rice. But when we talk about sustainable food systems in terms of nutrition, we talk about changing grains. And that's really the key insight I wanted to share with you. I'm kind of running out of time, but let me just very quickly talk about cooling. Cooling has a significant influence on well-being through many channels. I'm just talking about homes right now. I want to quickly breeze through this to make a couple of points. Everyone's concerned about air conditioning because it's a huge impact on energy, and it uses refrigerants that have a very, very high warming potential if they leak. And most of future air conditioning demand, half of it is expected to come from India and China, on the order of 2 billion air conditioners in the next 30 years. But what about people who can't afford air conditioners, right? It's a luxury item today. And so I'm interested in asking, where are the people who have heat stress or could have heat stress but don't have air conditioning? Because they could potentially die or just suffer labor productivity impacts and other kinds of effects of heat stress. So that was the question: where in the world do we find such people? And so we overlaid temperature above certain thresholds, above a certain number of days, to imply that's heat stress exposure. And we overlaid it with people. Where do you find people located with these temperatures? And where is it that they can't afford ACs? And we found, interestingly, that despite the fact that you have heat stress exposure across the world in these temperate and tropical areas, the places where the population who are exposed and vulnerable are concentrated in the same countries, India and China, where you expect that air conditioning to be sold. In other words, again, we have a major equity issue here where inequality is going to really, or the equity in development is going to determine who buys air conditioners and who suffers heat stress in these key hotspots. And so my interest now is to understand, with income growth and future climate change, who's going to buy air conditioners. And I'm going to jump past a few slides. I apologize for that, but I want to just talk about something in particular, which is that current models of thinking about air conditioning use tend to just assume it's a matter of income growth. And in terms of temperature, they kind of just think about cumulative cooling requirements as defining the threshold number of air conditioners any place would have. Hotter places would have more air conditioners, cooler places would have less air conditioners. But there are many other drivers. What about humidity? What about just the hottest days? If you think about New England, we have air conditioners here, even though the cumulative heating we need is not very much. Our cooling we need is not very much. Maybe the hottest days matter. Maybe nighttime temperatures matter. So I'm doing a lot of work presently to investigate the drivers of AC ownership. And I'm finding that many other factors are important. So climate is important to determine whether or not people own an air conditioner, but the type of climate properties that matter differ by region. So humidity matters a lot in Brazil and the United States, whereas in Mexico, it's a hot and dry. What matters is average temperature. Income matters, but to different degrees. And not in the United States because virtually everyone has one. Cities, people tend to have a higher ownership of air conditioners. And that is interesting because this might be social factors like peer effects. It may be accessibility of air conditioners. It may be prices. It may also be the urban heat island effect. So there's a lot of work to be done to understand who's going to own air conditioners in the future. And there's also work to understand the lifestyles of how we use air conditioners. As I mentioned, with minimal cooling, we have a very small amount of air conditioning that is required to avoid heat stress. But if you look at the usage of air conditioners comparing the US and India, we know that Americans tend to use much more energy for air conditioning. But if you look at per unit of floor space, and if you control for weather, they have very similar amounts of energy usage, which is kind of fascinating to me. And if you look at the set points, if you look at household surveys that ask questions that kind of hint at indoor temperature, Indians seem to be cooling their homes to cooler temperatures than Americans. And that was very curious to me because I would have thought that they'd be more money conscious, they'd be more adaptive to hot climate. Why is this the case? I'm still exploring this. I think this has to do with social norms and many other factors. The point here is structural factors matter. The size of US homes is a big driver of air conditioning use, even though on a per unit basis, it's not that different from India. But behavioral use matters, and it matters a lot. So there's a lot more work that needs to be done to understand lifestyles, to understand the equity of income distribution, to know who's going to own air conditioners in the future. And that's a really important part of demand side analysis as well. So my key takeaways are a deeper understanding of energy demand opens up possibilities for well-being enhancing sustainable consumption. I really want to stress this point that affluence really is driving future energy demand growth, not basic well-being. There are opportunities even in developing countries for equitable development and low carbon development, as I mentioned, with things like public transit. And overall, what I'm hinting at is evidence is showing that if we focus development on more basic well-being, if we consider moderation in consumption that does not reduce well-being, we can really reduce emissions growth and therefore reduce the scale of the decarbonization challenge. So thank you very much for that. And I really look forward to your questions. I apologize for racing through a lot of material, but hopefully the main points have been communicated.
Yes, thanks for all of the silent applauses, everybody. It's one of the things we miss from our in-person seminars, of course. Maybe we can do what sort of for questions. Folks are welcome to add questions to the chat line if you'd like, and otherwise I'll ask that you raise your hands and we'll try to keep track of who's raising their hands and go in that order. All right, I see Reese's hand up. Do you want to get us started?
Sure, yeah, thanks for the presentation. That was really great. Something I've been wondering about is just how, is it possible to kind of regulate affluence? I mean, that seems like kind of the whole point of affluence is that it's hard to regulate how, like, hard to tell people how much they can consume, or is it more of an issue of regulating the energy used to provide that service? Yeah, I guess that's what I was curious about.
That's a really important practical question. And I want to emphasize that as much as I'm trying to introduce a normative dimension to my research, that's not the main point here. Trying to generate more evidence about the impacts of different lifestyles. And I think there's two answers to your question. I think in a more practical sense, yes, one can tax affluence. One can do it through energy because the point is we're trying to focus on energy, or one can think more broadly about other effects of affluence. I mean, there are a lot of other environmental impacts as well, right? I know that in Austria, there actually was a proposal by a legislator to tax floor space beyond a certain size, right? So you can think about that kind of a tax. You can think of progressive income taxation. There are many ways to tax um, affluence, but if you're concerned specifically about climate, you can also do it through progressive energy policies. You have quantity-based pricing in electricity. The block tariff structure that can be used as a mechanism. Um, there's ways to introduce taxes on private vehicles, fuel economy standards that take into account the weight of vehicles, um, congestion pricing that discourage parking in cities. These are all indirect mechanisms that all actually tax affluence. So there's really a lot of available instruments. But I think you're asking a more fundamental question, which is how do you really get people to think about giving up stuff? And my hypothesis is that they won't give up a lot of stuff necessarily. And I'm doing research now. I'm actually writing grants to explore more quantitatively the well-being impacts of people's consumption and lifestyles. Because the literature on well-being is completely divorced from the environmental, ecological well-being literature. And I'm trying to integrate them. So when we have more information from people's own experiences, lived experiences, we might reveal that, hey, you know what? Actually, a lot of people, we find so many examples of people who have the same well-being and significantly different footprints. And I expect to find that. I know of communities in the US with that behavior, but I'm just trying to do it more rigorously, analytically, to let the evidence speak for itself on that.
Thank you. I'd like to move to the chat for a moment to get some of those questions in. We have one from Facundo who asks, for the demand side transformation, many of the paths imply long-term public policy, budget, and cultural change. How can developing countries that are mainly concerned with urgent short-term geopolitical and economic challenges focus in the long run with these policies? Sometimes one political party does take the required measures, but then another stops it. That's very common in developing countries. How can we assure a common worldwide participation?
Yeah, I don't know if I can answer that. Part of that question I can't really answer. I mean, it's a challenge that I don't really know how to address, right? The political challenge. I mean, the political challenge exists even in developing countries. I'm trying to indicate, I'm trying to call out developing country politicians too in my work, right? I'm trying to say, you know what? If you were to pursue public transit as the sole mode of transport in emerging cities in developing countries, you will reduce air pollution, you will serve low-income communities, you will reduce greenhouse gas emissions significantly. And that's a no-brainer regardless of whether you're thinking about climate policy. Healthy diets, similar issue. Better construction practices based on local materials, same issue. And I'm trying to bring out these very specific policies that developing countries can pursue that's in their own benefit, right? Having said that, we do have to decarbonize and there will have to be a significant amount of the responsibility taken up by us in industrialized countries to bring these advanced technologies, all the smart grid stuff I talked about, to developing countries to make them affordable. There's no way they're going to invest in it. So that form of international cooperation is indispensable. I know I still haven't talked politics, but I guess I don't want to because I don't have any more insights than you do.
Right. And we have a thank you from Facundo there. I think there's a quick question on the chat and then we'll pop back up to the live questions. Kristen asks, there are some examples of shared economy in the US, like laundromats that are viewed as symbols of poverty rather than examples of energy efficiency and demand side management. How can we shift perceptions around this?
Super, yeah. There's so many of these examples I've given you that deal with status, deal with, and I think this does require changes in fundamental values, and that is also unavoidable. What I'm trying to do is, like I said earlier, I don't want to repeat myself, is provide more evidence to indicate that perhaps we're being, we are not working in our own interest, right? And white rice in India is also the same problem. Coarse grains are the poor man's food. Laundromats are the poor man's, place to clean clothes. Well, the answers we've seen, before. Literature has shown us that you can use green marketing to make it, you can make green sexy, right? There's a lot of efforts to do that. Peer effects can work. I mean, if we just think about the marketing industry, I mean, they're experts at making things trendy, right? So really, I don't think it's hard. I don't think it's hard. As soon as you have a certain number of people who are motivated to push for political change, a lot of things can propagate from that. I think once businesses start to get on board, really when they understand that the demand for their products in the future have to be green, really not just greenwashing, I think the marketing will happen and just the way people's values are shaped today, right, by producers a lot. I think that can happen from better sources as well, from green sources as well.
So
yeah.
We'll move to some of the live questions. Dan and Cassie, I saw you popped up first. Since you already had a chance to ask questions at the beginning, maybe we'll try to keep the other two short and then get through all of you. So I think Meg, would you like to ask your question?
Sure. So here in California, we have a lot of speakers that come and talk about the need for increased energy storage and renewables and how much energy demand from those two will be required in order to kind of meet future energy. And I'm kind of curious, that seems like it could be a parallel between the conversation about how much energy will be required in developing countries as they because income increases and so on. But I was just curious if you think it would be possible to do sort of a similar study, but focusing on industrial countries, kind of about what sort of having this sort of energy hierarchy and kind of rethinking how much renewables and storage are really needed here.
Yeah, so so renewables and storage will be required no matter what, right? We will shift to an electrified society no matter what, and we will need to use solar power and storage. What I'm talking about is simply the scale of that system. That system scale can be shrunk significantly with demand side change, and you're absolutely right. In fact, the study that I talked about, the global study in global environmental change, I mean, my co-authors who was the lead on that paper actually have written it up as a sufficiency question, not as a minimum threshold question, which was my earlier work, right? Their thrust is, let's think about this decent living standard. It's not a modest, I mean, if it were a extreme poverty threshold, the finding would be trivial, right? But it's not. It's a pretty expansive view of a life. And why can't we live that life here, right? So certainly, I think there is a potential for advertising this energy hierarchy, talking about communities that use less energy, but we don't understand that heterogeneity yet. And that's what I'm trying to do now, is I want to look at heterogeneity of people's lifestyles and their footprints and their well-being, so that we can generate the kind of information you are getting at. I think that's a great direction of research for those of you who are PhD students or master's research students, MSc students, to really try and bridge the social sciences with energy research.
Thank you. Kelly, would you like to ask your question?
Yeah, I had a question related to sort of what I learned in like development classes in undergrad, which had a big emphasis on sort of family planning efforts and using that as a way to both like reduce poverty and greenhouse gas emissions. But how do you see that like fitting in, or is it like outdated? Or like how does it fit into, yeah, your idea of like development?
Yeah, that's an important question. First of all, the carbon footprint of a child in a developing country is an order of magnitude lower than the carbon footprint of a child in an industrialized country. That's one thing to keep in mind where we focus on, children. But there's been a lot of emphasis on population growth as a driver of climate. And the data shows that it's really affluence and not people with living on subsistence who are driving future growth. That's kind of what I'm even emphasizing with my work. But to your question more directly, other research, not my work, but people who study population, and I know this from YASA, the fundamental driver of female fertility is female education.
Mm-hmm.
That is the strongest predictor, right? So that problem will be dealt with just female education. This is not anything else, and we want that in any case for no matter what else we think about in terms of climate or environment. So to me, it's a moot point. It's endogenous to development. It's endogenous to human development that birth rates go down. So I do not think at all that is part of the concerns in climate mitigation.
All right, so I know we're kind of running out of time here, and I also recognize that Professor Rao doesn't have much time for our post seminar sort of lunch discussion. So how about we take, I don't know, Dan and Cassie, if your questions are short, how about we try to get through them, but I know some of you guys are gonna have to pop off the seminar.
Mine is pretty short. It was just about the how people in India are cooling their homes to lower temperatures than people in other countries in America. And I was just wondering if that could potentially be like overcompensation in both, like overcompensating that it's hotter outside so they make it cooler inside, but also overcompensation that they maybe could not afford to have the air conditioner, and now that they have it, they're like, I'm going to run it, maximum levels, Because I've noticed the same thing in my travels. It seems like places where it's hotter outside, people have cooler ACs inside. So
I think it's a nice hypothesis. It's like a nouveau riche kind of an argument, right? It's like, and I think it's possible. And I think there's status associated with it. I know in commercial establishments in India, for a fact, it's a sign of status when a retail store that you walk into, it's freezing cold. It's like shows that's how wealthy I am. Or a hotel, I can share an anecdote about that in the informal chat. It's kind of funny, but yes, that's a good hypothesis, and it needs to be studied. This is the data I showed are new surveys that have been conducted. There's a colleague I know in the UK who's doing a whole lot of new surveys of this in India, and we need this kind of fieldwork to understand, the new uptake of these devices.
Great, and Dan, if you want to.
Okay, so thank you for being here. And mine is actually sort of more of a research question. It's that in your goal, sort of to decouple GDP and well-being, you sort of introduced your own metric of decent living. And was that a hard choice to make? Were you afraid of pushback? And how accepted is that when you present your information? You're like, I'm using my own metric.
Yeah, it's a very good question. I was expecting more of a pushback. So in the climate community, in the research community, it's been really widely taken on. People have been looking for this because they understand the importance of a material an indicator of material needs, and this is pretty well justified. I mean, it's hard to argue against anything that I've said, really. People may argue for more, but I don't know how you could argue for less. I think I haven't presented this in the development economics community, and I think I'll get a lot of pushback there, because from a more theoretical perspective, because obviously this is you can't be prescriptive about this. I have actually left a lot of room in this for politically determined thresholds that, in fact, the actual values and content of each of these indicators can and should be determined by people on their own. There's room for that. So it's a very practical indicator. People, theoreticians who develop ideas of basic justice, they don't want to get so specific, right? So I've never presented to that community, But whatever communities I've presented this to, the only comment I get is, but in the future, isn't this threshold going to keep going up? Right? And I'm like, yeah, I'm okay with that. But my point is, it cannot be lower. And nobody, and I've presented this numerous times, I've got no pushback